go. Let's go to space.
Humanity's expansion into space will happen much faster than you think. The availability of microgravity and partial artificial gravity will enable activities and ventures that you just can't do on Earth. Activities such as manufacturing, pharmaceuticals, tourism, and many others. The question is, what are the steps that move us toward that? We're in the midst of the first step right now, a dramatic decrease in the cost of launching to space. This enables activities to be profit-making now that 10 years ago were uneconomical. The next step, these payloads need someplace to go, a destination. And the great majority of these activities will need pressurized vessels containing air, they need water, they need power, they need thermal control so you don't get too hot or too cold. And of course, particular commercial activities require specialized facilities and services. Finally, we need to bring some of these payloads back to Earth. Right now, the only facility providing all those is the International Space Station. But the problem is the ISS was designed as a research and development facility, not as a full-scale production facility. Space is limited, thermal control is limited, power is limited, and because of that, access is limited. That means there are thousands of commercial missions bottlenecked by the ISS and clamoring for an alternative. That is the need Above is addressing. Meet Prometheus, a modular infrastructure platform that meets a wide range of government and commercial applications. Prometheus offers in months instead of years access to custom pressurized environments, facilities, and services to support the needs of on-orbit product development and manufacturing at a fraction of the price of the ISS. Above greatly reduces costs by hosting multiple payloads on each flight with automation and using low-risk commercial off-the-shelf technologies. COTS technologies are very important because they avoid the cost, schedule, and performance risk of developing new technologies. Prometheus enables the development of the next generation of commercial space companies and is the cornerstone of our development program leading to long-term habitable space stations. The key to securing first-mover advantage is heritage. The Above team, with its decades of experience in spaceflight, space technologies, and mission architecture, is ideally positioned to take advantage of commercial off-the-shelf technologies, putting them together in creative ways to do things that have never been done before. Between myself and Robert Miyake, we have enough experience in spaceflight missions and operations to know what works in space and what doesn't work in space, and this greatly reduces the risks for the missions that we're designing in the future. And that's why the Department of Defense has entrusted us with a contract to develop our Archimedes platform, a platform that is rapidly deployable and a flat surface that supports many different applications such as radar, high data rate communications, and energy transmission and generation. My colleagues and I started Above because we realized we had a fast track to allow humanity to move to space and to make a profit doing so. We already have the letters of commitment to make this profitable from the very first mission. Prometheus is the next step in a wide range of critical infrastructure solutions. This is happening. We are going. And in phase 2, we'll begin to offer return of payloads to Earth. If you believe in the mission of providing more space in space, join us.
All right. Hello, everyone, and welcome to Fridays with Above, but on a Tuesday. Hopefully, you enjoy this new time. We're experimenting with when to meet with you all because we're trying to hopefully give you opportunities to join when people might not be able to on a Friday afternoon. For us on the eastern side of the United States, this is well after business hours. And for those of you on the Pacific side, hopefully you're done with your day and are getting ready to head home. But I am Tim Alatorre, Chief Operating Officer, one of the co-founders of Above Space Development Corporation. And I'm joined today by Rhonda Stevenson on this side, our CEO, and Dr. Tom Spilker, who you just saw in that video, our CTO. And we are excited to have you all with us today. And we've got a good turnout. So are we ready, Rhonda, Tom? Are we going to jump into this?
Yeah, let's hop in.
All right. Well, I'm going to push all of our faces to the side of the screen here. We'll bring up our slide deck. So I guess to start off with, we have grown our team. We've got a new addition. Dr. Elena Probst joined us. We're now, well, she joined us right at the beginning of March. So she's been with us now a little over a week. And Tom, do you want to introduce Elena to our investors and share a little bit about her capabilities and what she's working on right now?
Okay. I first met Elena at a meeting in Marseille, France. She had gotten her PhD from the German, let's see, it's the University of the Armed Forces Munich. Her PhD is in system engineering and various aspects of space engineering. She knows a lot about space systems and all of the systems needed to do a space flight mission, including orbits. In fact, she was a postdoc at the Jet Propulsion Laboratory for 2 years on a project where she was doing orbit calculations regarding reentry vehicles, and actually not reentry, entry vehicles going into planets from an interplanetary approach. She has a good feel for how mission projects are organized and the steps you need to go through to organize the different products that are required to successfully make it through a project. So we're very happy to have her here at Above.
Yeah, and we'll talk about this more in a minute when we get to talking about Prometheus, but she's already gone headfirst into the Prometheus project. And actually, before she started, she met with you. And for those of you who were at our demonstration of the D-Star, at the time, Elena, was she working with your wife, Linda, over at JPL at the time?
She was working with Linda at JPL at the time, and she was thrilled to get a chance to work on some actual hardware that she could put her hands on.
Yeah, so Elena came and volunteered for a couple of days over the D-Star event, and she was there. So she might be a familiar face to some of you, but we are excited. It's been a long time coming, I think, for her to actually join our team full time, and we're excited for the skills that she's bringing to the table. And that into what we're doing. Well, I mean, everything, I guess, Prometheus, we started the video today with Prometheus. We're going to end with this call with Prometheus. Everything kind of ties into Prometheus. But just a reminder, everybody, we are still working with NASA under our Umbrella Space Act agreement, specifically with Prometheus. We did the testing last November, was the last round of testing, but we're gearing up for the next round as we prepare some of the end models for, I guess, pre-check and validation, as well as all the battery of tests that will happen to make sure everything is working. Tom, what are some of the tests that we can expect to do pre-flight for our Prometheus mission?
Oh, as you said, there's a battery of tests, quite a list. You need to do what they call thermal vac. You put the spacecraft in a vacuum chamber, and from one side you light it up with really high intensity lights, simulating the sun, and then the rest of the chamber has liquid nitrogen circulating through cells around the sides of the chamber to simulate the cold of empty space, to make sure that your spacecraft is not going to either overheat in places or freeze in places. And you do this at various attitudes with respect to the simulated sun, and just make sure that your spacecraft is robust to the thermal aspect of being in space. There will be other tests, such as one they call the shake table. In space, there's not a whole lot of force you have to put up with, but when you're launching on a rocket, that rocket just shakes the heck out of you. You get G loads of several Gs in every direction. So they take your spacecraft in the configuration it will be for launch, put it on this shake table, and then simulate what that launch vehicle is going to do to it, and make sure that you don't wind up with parts flying off and hitting the walls and so on. There's also electromagnetic tests. There's electromagnetic interference, where you look at different parts of the spacecraft. How sensitive are they to signals coming from outside of the spacecraft, such as a launch vehicle or something like that, or something radio signal coming from the ground, making sure that it's robust to such interference effects. And there's electromagnetic compatibility to make sure that things that are part of your spacecraft don't interfere with each other, such as the radio system doesn't interfere with the primary computer. These are some of the major tests that we'll be doing. And then, of course, each individual component will be going through its own tests for various things, such as function and amount of power drawn and various things like that.
And I think one of the important things to recognize and how that ties into this, our Space Act agreement, is we don't have to build or purchase a thermal vac chamber. We don't have to build or purchase a shake table or create our own EMF test chamber. Those are all available at NASA. And not only do we have access on Space Act agreement to those amazing facilities, multi-million-dollar facilities, but also all the expertise and the spaceflight heritage of people who've sent countless things to space through the year and know how to set those facilities up, operate them, and know what it means in the actual space environment. There are other commercial testing facilities around the country and even here in Huntsville, but their testing isn't necessarily space focused. And the expertise at NASA is space focused, which is a huge advantage, I think. So we are very excited, grateful to NASA. And our work continues on our Archimedes project under our SBIR agreement with AFWERX. And we've got 2 milestones remaining. I think we're wrapping that up, the whole project in May, if I'm not mistaken. We've got a couple more months. And we continue our outreach to the DoD for end users and eventual contracts and customers for Archimedes. Rhonda, Tom, anything else you want to add on Archimedes and our press? I know a lot of it we really can't end up talking about publicly, but
well, we did do a demonstration there in Huntsville in November, where we demonstrated transmission of electric energy at microwave wavelengths across empty space, no connecting wires, and produced a measurable amount, well, more than measurable, a significant amount of electricity at the other end of that transmission link. We were able to do such things as light up a bank of LEDs and light up some test equipment and charged up some batteries, which is something that frequently will be done in orbit. Charge up batteries over a certain amount of time and then discharge them in a smaller amount of time so that you can get higher powers. And then we use those batteries to power a laser to pop some balloons.
The only other thing that I would add to that is we did have the opportunity to brief DARPA in January on Archimedes in their power division. And that's a conversation that continues with some follow-up. And we are also looking at or discussing with folks within Space Force for the next steps with Archimedes.
Yeah, those conversations, I think we can safely say there's a lot of interest across the DoD, well, specifically Air Force, Space Force, some of the research institutions. It's just a question of figuring out those bureaucratic processes to get to the next step. All right, and then something we're very excited about. We're going to space. We were supposed to have launched our payloads last Monday. So we are on the Missy 19 platform, which is launching on STX, 30? And initially, so this is a mission on the Dragon Falcon 9 rocket that's going to ISS. Initially, we were scheduled for the 4th, but the crewed vehicle, that was delayed until the 3rd, which pushed us back. And then that vehicle had to dock. Astronauts had to safely get to the ISS, and then the departing crew had to get back on that Dragon vehicle and come home. And so I think they are now home, and so we are rescheduled, subject to change because they keep bumping us. But right now we're looking at flying in the afternoon of Thursday, March 21st. That's the current date, launching from Kennedy. And I think, we've been talking with many people about just how challenging it is to fly payloads on the International Space Station. And Rhonda, we're getting to live it firsthand now, just with the uncertainty and being at the whim of the NASA processes. The payload integrated and sitting on the rocket, in the fairing for well over a month now, and we're just waiting for the green light to go.
One other thing that Missy has pointed out to us is that if you're flying on a platform like Prometheus, there are a lot of requirements that you don't have to meet because you don't have to be human rated. Prometheus is fully automatic. And if you're flying on a human rated spacecraft like the International Space Station, you look at the requirements that your payload has to pass before they'll let you go up there. And they will tell you such things as, well, here's the list of the materials you can't use. And it looks like what used to be a New York City phone book. There are many, many difficult requirements to meet to be able to get to the International Space Station. And because you won't have to meet all of those human rating requirements, the cost of building a platform or a payload to go on the Prometheus spacecraft will be much reduced as compared to what is necessary to go to the ISS.
Not only the cost, but there's things you can do on an automated platform that you can't do with a crewed vehicle. There's certain materials that are prohibited, certain processes that are prohibited. So there's additional opportunities for commercial activities. And then I think the big bottleneck, I think this March flight is the last NASA endorsed flight where there can be purely commercial activities. They are going to a scientific value only model moving forward. So companies that want to put something up just for commerce purposes don't have a place to go right now, which is good for us with Prometheus, but bad for the people who know about Prometheus, I guess, right? And so the Missy mission, which is going up soon here, that the process of that is that payload is going up. The astronauts will take that platform and mount it. Astronauts will mount it to the exterior of the International Space Station, using Canadarm, I'm guessing. That's what they do, right? And then that'll sit out there for 6 months exposed to the space environment. And then sometime later this year, that payload will be removed from the exterior of the space station, put back on a return vehicle, right now probably a Dragon capsule. And then we will get those materials back in samples and experiments in early 2025. And then we'll then pass on our customer payloads back to them. But Tom, do you want to talk about the significance of having our payloads outside ISS and not just sitting inside?
Certainly. The space environment can be very harsh. There are a lot of things that you're exposed to in that environment up above our atmosphere that you just don't see down here on Earth. There's the radiation environment. There are certain reactive species up there, especially atomic oxygen from oxygen molecules from our atmosphere that the sun has split up with its ultraviolet rays. Ultraviolet itself is really hard on materials and various things like that, temperature swings. We take materials up there and expose them to these different conditions that you see in the space environment and see which materials seem to do well and which ones don't do so well, so that when we're designing our especially inflatables like Archimedes, we know what materials will work well and will be durable in that space environment and know which ones we should avoid.
Yeah, which is very important for when we go to larger platforms. And then we also have 3 customer payloads that we are flying. And that was a fun process because we got those. Well, the customers, we really collaborated with them to help them design and integrate their experiments and what they were doing. And their payloads came to our facility here in Huntsville. And in a glove box, we integrated them, prepared them all. And then Rhonda, you physically picked them up and took them to our integration partner in Houston. And actually, so ShipShape Urban Farms is one of our customers. I think we put out a social media post about that. And there's a picture of them handing off that payload to you. Rhonda, how was it to know that you were the guardian of these important experiments and payloads, and that you were solely responsible for their safe delivery?
Well, it was definitely a carry-on kind of situation, flight from Huntsville to Houston. And it was neat. It was really cool, and you know, you're holding these little samples, and you know, we have all these plans for all the different samples and all the folks that we've partnered with, and you know, it doesn't really get real until you hand those samples off to the custodian and you see the platform that these samples are going to be mounted on, and then you see the real hardware and what's going to be exposed into the vacuum of space, and then it kind of sinks in that it's real and it's really going, and this is going to be out in space. It was really neat.
And then hopefully, how many days? 9 days or so, you'll get to see it take off on the rocket and head to space. And we will be getting photographs of the payloads in orbit. We'll see what we can share. But yeah, very excited. So I am seeing in chat that there's some issues with the stream. That is more than likely a local issue. I'm looking at our stats here, and we've got good signal. So this recording will be available afterwards if you're having a hard time following the conversation. All right, and then that brings us to Prometheus, and there's a lot of text here. I apologize, but I think we put this in here, Rhonda, and I'm talking to Rhonda because she and I put the deck together. But because this is really the crux of what we're doing with Prometheus. As I mentioned earlier, NASA is not accepting solely commercial experiments. And so there is significant demand for commercial payload activities in space. And that's where Prometheus is coming in. And I think we had started this process with Prometheus before we got that news about NASA's policy change. And what's become apparent to us, I think, or at least to me, Ronnie, you probably already knew this because you've got you know everything that's going on in the space community, but like over the last 6-8 months, as we've been really doing customer outreach and getting those conversations with people, the need for Prometheus has become very apparent. And so the goal for this first mission is to demonstrate our capabilities to build and implement a fully integrated and free-flying spacecraft. And not only that, but doing it in an affordable and fast way to allow for those technology developments, research, future experiments. Rhonda, do you want to maybe talk a bit more about why Prometheus and how this fits into, I guess, the need in the commercial space?
Yeah, absolutely. It's kind of our mission to provide more space in space. But why do you need more space in space? And as you were saying, Tim, the accessibility to the ISS is going to become much more limited, increasing the bottleneck. And with our intentions for Prometheus, which is to validate our hardware and to demonstrate, as Tim had said, that we can operate a spacecraft on orbit, and that fits along our technological roadmap of wanting to scale to habitability and provide all of the features of comfortable habitability that we've discussed previously. But we have to take the first step somewhere. And with that, it's with Prometheus. What was really great for this mission is that it just so happens that in our own efforts, we are also able to host commercial customers. When we were originally designing Prometheus, that was something we had considered, but it wasn't a major consideration. And now it's a factor that presents a wonderful opportunity to us that after costs of Prometheus and getting a leg over on completing this mission, we're looking at potentially being, well into revenue positive with this opportunity. The other part about Prometheus is that it's very duplicatable, it's scalable, and with that, not only are we signing up customers for this first mission, but there are also more inquiries and continuing interest in future missions. So we are now establishing our own continuous customer pipeline with Prometheus, and so we're looking at how many future launches is that? How can we accommodate these customers quickly, efficiently, affordably, and providing them with the features that they're going to continue to look for, because they're scaling too. They're wanting to test and validate their experiments and their research, and as they learn and as they grow in their capabilities, they're going to have more demands about what they're going to need for next steps. And a lot of those aren't necessarily available with the ISS, even if the space was available.
Yeah. Oh, Tom, you want to add something?
Not at this time.
Sorry, I thought you were trying to say something. So
No.
Jamie is asking a question in chat here about how big are those Prometheus boxes? And I think we've got the one pager, which we're distributing without NDA. So I'll share what's there. We're purposely being a little vague about specific dimensions and capabilities on Prometheus because, and we'll get to this in a second, there is growing competition in this space. We're not talking about a couple of small CubeSats though. We total on the platform, we have over 150 U of payload space. So a U is kind of the standard CubeSat 10 by 10 by 10 centimeter cube. So that equates to about a 1.5 cubic meters of payload volume. So it's not small. It's not a toy. It's not something we're going to stick in the back of our car and drive around. We will have to have special accommodations to transport it. But this isn't space station size where a person's going to be able to get inside of it. But it does pave the way for those platforms. Tom Crosby's asking in chat, do we deploy and then bring back home, rinse and repeat? So repeat, absolutely. Like Rhonda was talking about, we in Prometheus as a rapid cadence platform, and we're already looking at subsequent launches from this first one, build them simultaneously. It's all driven by customer demand. We're feeling out right now what our customers want. Some want very small size, some want bigger size, some want the entire spacecraft, and so as that demand starts to solidify, and actually here I'll go to the next slide here because these are kind of the next steps. As we're solidifying that customer engagement, getting deposits and actual exchange of funds, that will determine how frequent we can build these things. We are looking at return capabilities, but that's not in this first mission. The market does want that. They want to be able to bring stuff back eventually, but right now there's a lot of people that just need to get up there and get data back. And then we did complete, let's see, what was February? I think we completed PDR, and that is preliminary design review. We go through all the systems, subsystems, top to bottom, budget, schedule, figure out where all the holes are and gaps, and make sure we're coordinated. And now we're working speedily towards CDR. CDR, what's the C stand for, Tom? That's
critical design review, and that's where not only do you have the systems involved and so on, here's what frequency we're going to be sending along this coaxial cable, and here are the signal levels that are going to be sent, and it will go into this port of the modulator, that kind of detail. You don't have yet the thread pitches on all the mounting bolts that detailed design happens at after CDR, but the CDR lets you know that, okay, your design is to the point that you can do all of the detailed design and get it down to the blueprints and start building some hardware.
And that's where Elena has really been invaluable. She's a fresh pair of eyes. She came on after we had completed PDR. So it's great. She's gone through and she's reviewed all the PDR documentation. We recorded the 3 days of PDR sessions. That was like what, about 24 hours of sessions for PDR. And I think Elena's watched all of that video. I feel so bad for her. But, having that fresh pair of eyes, and she's going through and I think a big piece also that we're working on right now between PDR and CDR is all the risk management process, and just trying to identify every possible thing that could go wrong, and figuring out the probability and how critical that is. And Elena's done a great job of, I think, bringing in some of the NASA processes and refining our system. So that's an important step we're going through right now as well, which I'm sure you can imagine is very, very labor intensive. And then we're starting to receive customer deposits, and that, as Tom mentioned in the video, when we recorded that video, which I think was like November timeframe, wasn't it? October.
It was October.
Yeah. So at that time,
yeah.
So at that time, we had letters of commitment to fill the form and more, and those letters of commitment, there weren't funds exchanged yet, and so now we're moving those from letters of interest and letters of commitment to actual deposits and finalizing what those payloads are going to be. And so that's something that we need to get the payload manifest solidified to complete CDR. There's some long lead time items that we can work on before then, but for our customers, though, the advantage of Prometheus, besides just having a right of space, we're providing them power, thermal control, communications. We didn't put on here, but attitude and pointing, which is a key part of having a working space platform. Anything else that we want to mention about Prometheus? This is your chance, Tom. Oh, I should probably talk about where we're going. So right now we're looking at a mid-inclination flight. So that's about 30 to 60 degrees. And we're looking at around 400, 450 kilometers altitude. Right?
Somewhere between 400 and 550, most likely the lower side of that. It would be nice to get the 400-kilometer orbit for a couple of reasons. One, the orbit period is shorter and you get more passes per day over the ground stations, and you're a little bit closer, so you get higher data rate during those passes. You're below the altitude of the International Space Station, so you don't have to pay a lot of attention to avoiding collisions. In fact, you have to pay no attention to avoiding collisions with the International Space Station because you're lower in altitude than they are. And that would be a problem if, say, we were up higher and the mission is over and the spacecraft starts descending in its orbit because of the very small amount of drag that's still present up at those altitudes. If we start at 400 kilometers, we don't have to worry about that altitude crossing the altitude of the International Space Station. And it provides a fairly rapid reentry. The excuse me, the average time of reentry, and of course there's variation of the atmosphere depending on what the sun is doing, but on average it should take something like 450 days to reenter. So we don't have a piece of orbital debris that would be up there for years and years. There was a question about, do you bring it back home, rinse and repeat? Yes, we repeat, but we're not bringing it back home in a state that we could relaunch. It will burn up on reentry.
Yeah, the goal is to not have anything sizable impact any place on the Earth's surface.
Now that said, we've talked about further down the line offering material return capability, and we're well along in the process of developing that capability. It's just it won't be happening within the next 6 months or a year. It'll be a little further down the line.
Yeah, I think so. We've been looking at, like you said, a number of different aspects of that, because that problem is multifaceted. There's regulatory and technological and operational processes that all have to be coordinated and solved.
And with that foresight,
Rhonda.
we are currently engaging in those conversations so that
Oh yeah,
when we are ready for those return sample missions, the regulations and the licensing, we've already done those due diligences.
yeah. So there's a couple of questions in the chat here related to Prometheus. One is just asking if these are solar cells on Prometheus. Yes, we have. They're just actually on this one face that you're seeing here. On the back side, we have radiators. So we have the energy system has to be balanced. You don't want to get too hot. You don't want to get too cold. And so we've got PVs on one side, radiators on the other side, and the solar panels would always be, well, oriented towards the sun as much as possible to keep batteries charged. And then there's one other question here. Well, Tom's got two. I think one I'll throw to Rhonda, and the other one I'll throw to Tom. So the one for Rhonda is: are there any business model linkages to SpaceX's ship?
Are there any business space models to Starship? Is that the question? You cut out
Yeah.
just a little bit, so I didn't hear the whole question.
Yes. Are there any business model linkages to SpaceX's Starship?
I have not seen any. That doesn't mean that they're not out there. Right now, our business model use case for the Prometheus platform is smaller scale. Targeted customers would be pharmaceutical companies, prototyping companies, material science companies, folks who are looking to put their, let's say, wares in an on-orbit environment and make observations and get a greater understanding of the behavior of those experiments. And then they're kind of, take that information and then repeat would be a future mission with potentially return sample capability. That's a fairly consistent model for what the current demand is in the market right now for space platforms. And therefore, it would make sense that at some point that would also be mentioned or modeled with SpaceX Starship. But Starship is intended to be a much larger platform and to be habitable. And so the current capabilities of some of these companies that are taking their first steps into space, by the time we get there, who knows what they'll be doing, but it'll be exciting.
And that said, if the Starship is available 5, 10 years down the line, when we're looking at doing such things as our Pioneer or Voyager stations, with that kind of launch capability, 100 or 150 tons to low Earth orbit, if they give us a good price, hey, we'll talk with them.
Yeah. Instead of doing 6 launches, we can do it all in one launch, which is fantastic.
Yep.
I think you bring up a valid point there, Rhonda, which is something that is important when looking at those Starship in particular. We are future proofing and looking at what we can do with Starship, but the market right now is needing the scale of Prometheus. That's what people are needing right now, which is why we're delivering it. Next question.
I just wanted to make one more comment on that without beating it to death, because this isn't the exciting stuff. The space stuff is the exciting stuff. But having said, this is I think a really good illustration how I think that you hear Tim and I discuss frequently about the bottleneck on the International Space Station, and what does that mean? And we usually reference that in terms of time, that if you were a company right now wanting to vet some samples, grow some protein crystals, do some sort of experiment on the ISS, if you pass muster with all of their requirements, you're still looking at a really long time to do an astronaut-assisted experiment on the ISS, and that availability is actually becoming more scarce, as Tim had mentioned earlier. What Prometheus does is it takes away the need for that bottleneck and provides a replacement for a lot of that emerging science and development to take place. I hesitate to say research because I don't want this to be misunderstood as a science project. This is actually the next step where we move into the commercial markets of what's available with on-orbit manufacturing and more complex systems.
And then one question for Tom, do we have any deorbit safeguards? And I'm assuming Tom's saying like when it comes time to deorbit, not rapid, unplanned disassembly while in orbit.
Right. The most reliable deorbit scenario we have, the deorbit process we have, and it's very reliable, is Earth's atmosphere. As I said before, just the standard Earth's atmosphere at the altitudes that we want to be operating at, 400 kilometers, with the mass and surface area of the Prometheus spacecraft, if we did nothing, it would come down in about 450 days. We were entertaining the possibility of doing an active deorbit, but it requires a fair amount of propellant and some fairly large rocket engines that would be driving the structural design of our spacecraft. So we're going to rely on Earth's atmosphere to do that deorbit.
And I think we have talked about if there's some excess propellant after our base mission, we would fire the thrusters to accelerate that possibly.
Yes, we can hasten that deorbit by reducing the perigee and getting it down into denser atmosphere.
Mm-hmm. Yep. All right. So, just a reminder kind of where we're at. Back in 2019, I'm fairly certain, or at least in the conversations we were having and the circles that we were going around in, I think, above at the time, we were going by a different name. We were the only ones that had a commercial company talking about artificial gravity that were making, equity participation available for anyone really. Now we've seen over the last couple of years, additional companies that are now talking about artificial gravity, and we're seeing that inevitable progress of others innovating on this concept and seeing other companies stepping up. I think to something we've seen some time ago. We still feel. I'll make it for me because I want to talk for Tom and Rhonda. I feel we still have the competitive edge, and with adequate funding and the customers coming, I think we can still beat our competition. If not to be the first to market with a superior product, because it's fairly easy to make something spin, but to make that a usable artificial gravity, I think is an advantage we have, especially Tom with your expertise in space system architecture and design.
As you say, it's easy to make something spin. It's harder to make it spin in a non-haphazard way.
Right. Yeah. So, and with all of these offerings, that the market is clamoring. Others will be coming online, but we feel like we're leading the way, and thank you, all of you, for your participation in that. Many of you were in those early days of participating in the company, and great things are happening. And just a reminder, this is where we're at. So right now we're with Prometheus and Archimedes. We're working on those projects, and then they paved the way for Station in a Box. The technologies needed for Station in a Box are all encompassed in Prometheus and Archimedes, with the exception of life support systems, which we've got some excellent vendors here providing those. And then we stepstone from that to Pioneer and larger gravity stations like Voyager. We, I just want to remind everyone we're working on these near-term steps. We haven't lost the vision. It's still there. Let's see here. And with that, let's see. Oh, yeah, we do have some news. Trying to remember where we're at in the presentation here.
Just
So,
Tim, can we go back to the slide, the previous slide?
Yeah.
Just out of curiosity, maybe by just a ping, I'm just curious if there's anyone on our briefing call today that was at the D-Star demonstration and has been able to participate, all along with these calls and updates that we've gone from the D-Star demonstration to launching next week some samples to the ISS, and then what we will be doing with Prometheus.
Yeah, if anybody is able, just drop in the chat. Just let us know if you were at the D-Star event. Jason Cole, he was there.
I was there.
I was there.
Tom was definitely there. Yeah, the three of us were there. And there, the problem is like there's so many familiar names in chat. It's hard to know if they were there or not. Well, Jason in particular, who's commented in chat, thank you. Absolutely, thank you. And Tom says he was. Oh, Sean. No, Tom says he was here since the beginning, but not at the D-Star event. And Sean also says he was an early advisor, but not at the D-Star event. And so Wayne's asking about options to watching the above launch in person. So we're not really doing a big public event for this launch. Maybe for Prometheus, we'll do something bigger. I don't know. Coordinating events around Florida, around launches is incredibly difficult, as we've discovered. Not only does the timing change 5 or 6 times, but then just the venues are hard. I think with Prometheus, that wherever we end up launching from, that will be more of a known quantity because we won't be going to the International Space Station. Dean says that the D-Star video is what convinced him to invest. And
Awesome.
Narendra also said that they invested right after D-Star. So, yeah, well, thank you all for being here with us.
Thank you.
Well, and I guess that brings us to this next piece of news, right? We are ending the Reg CF raise on March 31st. And right now we don't have plans to do another Reg CF offering, right? We are, and I think we are as definitive as we can be that we won't be doing another Reg CF offering, but I don't want to put a stake in the ground and say definitively we won't again. But we're really, we've been really focused on those accredited investors, any really accredited investors, right? We're actually, we'll get to that in a second. I think that's the next slide. But raise is ending March 31st. And just a reminder, the Silicon Prairie platform, it's a unified platform. All the prior raises, anything that you invested in at Capital, the warrants, anything with Silicon Prairie, it's all there. Silicon Prairie is our transfer agent. They are keeping the official records for all shares. And then warrants, if you qualified for warrants under the Q1 raise of 2023, those are exercisable until December 31st of this year. So even though we're closing the Reg CF off, that is still open and available to you. And then when this raise closes, we're going to start working with Silicon Prairie to enable the trading platform. So anybody who owns shares through Silicon Prairie will be able to buy and sell through the platform. And we've had some early conversations with them about that. We need to work through the details. And so I'm not going to say definitively when that will go live, but that is something that is in the works. And then as always, we have the Tiger Mark insurance policy that doesn't have an expiration date. So, that's something we put in place just as another level of protection for your investments. And so Bill's got a question about the platform. Bill, if you want to go ahead and just email, you can email me or info@above.space, and we'll sort out that technical problem. It's hard support on these kind of calls. So next steps. Rhonda, what's next? I'll let you take this part. I kind of stepped on it earlier, but.
Oh, no worries. Well, I've had this this conversation, this statement, a couple times now, getting on these calls. I think the most important thing that we always want to convey to all of our investors are thank you. Thank you so much. Thank you for your investment. Look what we've been able to do in a very short amount of time. It's amazing. It's unprecedented. And I'm so proud of our team. And we wouldn't have been able to do it without you. Thank you. For next steps, we do have to move into accredited investment. Doing work in space is expensive, and we need to do the things that are necessary to be successful at that. And so with that, March 31st will be the last day that the CF round platform will be available and accessible. And then we move forward with accredited investment, primarily seeking investors for convertible notes. And if anyone on this call is interested in having that conversation, please email us at invest@above.space. And I think that that's it in a nutshell. We encourage you to please reach out to us with any questions that you may have. And with that, Tim, did you have any other remarks about next steps?
Yeah, I think that's a good summary. I mean, from here, we're going to space in a couple weeks, and we're just going to keep going to space. That's the next steps, right? I mean, we are at that phase, and I do appreciate you, Rhonda, just putting in there the plug of if they have questions, reach out to us. We all get a lot of emails, and so I do make a point of scanning my email regularly for anything from you, our investors, and trying to not let things slip through the cracks. But if it's been 4 days and you haven't heard from me, at least go ahead and just send me another email. We will answer your questions as we are able. There's some things that we can't talk about yet, but we will share what we can.
I think that the other thing that we try to capture every time that we have these briefings is the partnership that we have with all you folks. And the celebratory statements of saying, hey, look what we've been able to do, and look where we're at in a short amount of time, and again acknowledging that you all made this possible, and we want to continue those conversations. We will continue to have briefings. We will continue to reach out to you all and give you these updates. You are still in this journey with us, and we'll continue to be. The only difference is we won't be discussing a crowdfunding platform. It's not that, okay, that was great, thanks, we really appreciate that. It's that, no, this conversation continues. You are in partnership with us, and we all want to be able to celebrate that with all of you.
Yep. I was just going back, scanning through chat. There are a couple of just real quick questions I think we can touch on. There was a question from George if like the thermal, TVAC, vibration, EMF testing could all be done at one NASA facility. Marshall has those facilities. There's a variety of NASA facilities that have different capabilities, like thermal vac chambers are, I think most, if not all NASA facilities have some thermal vac capability, right? But Marshall's just the road from our facility. It's not even 10 minutes away, so it makes it really easy. Well, it's 10 minutes to the gate and then like another 10 to the environmental test facility. So we'll call it 20 minutes. And then Sean was asking, if we could share an estimated timeline of when the first Prometheus launch would be. I think it's safe to say within the next 12 months. We can say that. Yeah. There's a couple of factors we're looking at, the launch providers being the key one there. And our customers. Those are two things that we have to balance. And then Jamie had one other question. This is a Tom question. Jamie likes to ask you questions, Tom. He's wondering, how crowded is the 400-kilometer orbit layer? And I think once you answer that, then we can call it a night and say goodbye to everybody.
Well, one of the advantages of the 400-kilometer altitude is that there's still enough Earth atmosphere left there that very few things last very long there. If you're really heavy and small meaning small surface area exposed to the atmosphere, yeah, you might last 3 years or 4 years, but most things come down in much less time than that. If you go up only 100 kilometers to 500 kilometers instead of 450 days, you're looking at more like 1,000 or 1,500 days duration up there. So the 400-kilometer altitude is relatively free of at least what we would call orbital debris. Some of that is spent second stages and dead satellites, but also most of the really populous satellite constellations like Starlink and so on are further up above that. So 400 kilometers is not bad.
I think something that when talking to people forget is that the area around the Earth is a sphere. And so as you go to higher altitudes, there's more area, right? And that isn't a linear increase. And Tom, you could probably tell me exactly how that area grows. But as you go higher, there's more room, and as you get lower, there's more likely collisions just from the.
As you go higher, there's more room and fewer molecules to run into.
Yep.
It's what they call an exponential atmosphere, modified by temperature that varies all over the place as you go from the ground up.
Yep. And I think the key thing, as you mentioned earlier, is just keeping away from those habitable stations. Well, there's a lot of things we want to keep away from, but especially where people are, right? That's a utmost priority. Rhonda,
I'll not to run into anything larger than a molecule.
Yes, absolutely. Well, and even those can do some damage, depending on what it is. Highly charged particles from the sun. Rhonda, I'll leave it to you for final thoughts, and then we'll bid everyone goodbye.
Just final thoughts as always. Thank you, everyone, all of you. Thank you for your support. Thank you for your continuing support. Please reach out to us if you have any additional questions. Stay tuned. We'll be offering updates with the sample mission next week, and future updates on our progress with Prometheus and timelines, and other exciting announcements as we progress deeper into what the evolution of a consistent Prometheus platform looks like. And we just can't tell you how much we appreciate sharing the journey with you.
Yep, absolutely. And I can see from your background, Rhonda, the sun's been setting.
Yeah,
You were brightly
it's
lit
kind
when
of
we
dark.
first started. So that means it's time to go. So thanks everyone for joining us, and we'll see you on the next call.
Thanks,
Ad
everyone.
astra.